Welcome back, Math 30-1. So we're continuing our travels with playing with functions or operating with functions. And so so far in your travels, you have added two functions together and seen what you've created, adding two lines or adding any two functions. You've subtracted two functions and you've come to some conclusions. And in the last lesson, you've multiplied two functions together and you've created new functions with those operations. And this one is kind of special because division is kind of interesting. So what you want to do is, again, it's an investigation. So please fill in the chart and play with the math, do some math gymnastics and play with the math and see as you do question what's going on and dig deeper into the questions that are asked here about domain restriction and so on and make some meaning of that to yourself, and then we'll come back and chat together. So complete the investigation and then we'll come back and see how our investigations match up. So as you filled your table of values, you notice that g at x on the chart, on the graph, that g at x was the line and that the parabola was f at x. And as you consider what happens when you take f over g at x, clearly f over g is 7, and then it's going to be 6 over 1, which is 6, and then it's going to be, that is undefined, right? We cannot divide by 0. And then we're going to get 4 and 3 and 2 and 1 and 0 and -1. And as we graph those values, we see what we get. Uh, so in the next question, explain why the domain of f over g is not all real numbers. Why does that not go on forever? Well, clearly, we have a non-permissible value. Because this graph is undefined at 0, we clearly have a statement that we cannot have x equal to 0. Sorry, we cannot have x equal to 2 because at that point it is undefined. So the domain would be the set of all values of x such that x cannot be equal to 2, but it can be an element of reals. Now that's what the domain is, but the reason we can't have it is we should actually, when we are asked to explain, we need to make a statement. And the reason that is f over g at x is not defined when x equals 2. In other words, when you have x equals 2, then we have 0 in the denominator. It's undefined. Sketch the graph and show the restriction by drawing an open circle. So as you graphed f over g at x, you get the blue line there that goes forever except it has a hole at an x value of 2. So the hole occurs at actually 2 and 4. There is no point there. The functions f and g above were actually those functions. Rate and simplify what that actually is. So if we have f over g at x, we have x squared plus x minus 6 all over x minus 2, which becomes x plus 3 times x minus 2 all over x minus 2. And these two factors here are the reason for the hole, because if you plug in 2, you get 0 over 0, which is undefined. If we algebraically simplify it, we essentially have in our blue graph a graph of the line x plus 3, except it has a hole at 2, and that hole is actually at a value of 2, and 5 is a hole. You can't step there. What is the value of the function at -6? Well, clearly that's really easy to calculate. F over g at -6 is equal to -6 plus 3, which is equal to 3. As we continue on in our investigation, just make note and have a read. Stop and read. We talk about holes and points of discontinuity much more later in this book when we talk about rational functions and so on. There are points of discontinuity that result in rational functions when we have non-permissible values. In this investigation, the quotient of a quad function and linear simplifies to a function with domain restrictions, but this doesn't always happen. There's lots of interesting cases that we'll discuss when we do rational functions. And now investigate and simplify examples 1 and 2. Write and simplify where possible, so you can pause the screencast and you can go and give these a try. And when you consider f over g, are there any domain restrictions? So in the first question, we were asked to do f over g at x. So f over g at x here is 2x plus 5 all over x plus 5. And there is a domain restriction. In this case, our NPV, non-permissible value, is we may not have an x value of -5. In question B, we still want to do f over g at x, and so we've got x, I'm just going to factor quickly, x minus 7 times x plus 5 all over x minus 7. So clearly we can see that this is going to simplify. That will simplify, but that does not change the fact that we still have a non-permissible value of x equals 7, and that's, whoops, x may not equal 7. So there is a restriction on that domain there. And in C, we have f over g at x, and that is going to be x minus 2 all over x minus 3 times x minus 2. And we can clearly see that that will cancel, but now our non-permissible values, or restriction on the domain, is x can not only not equal 3, but it may also not equal 2 as well. But it does simplify, oops, I forgot to do that. It does simplify to 1 over x minus 3, just as this one simplified to just a simple line of x plus 5 that has a hole, right? And we'll talk a lot. Number C is special. It has a hole, but it also has an asymptote, and we'll talk about that more in rational functions as well. In example 2, consider the domains of f and g. Well, with the domains of f and g, we know that f is a parabola, a happy parabola, a y-intercept of negative, happy parabola with a y-intercept of negative. We know that parabolas have domain of real numbers. G is a line, slope of 2, and a y-intercept of 1. So we know a line has a as long as it's not a constant line, constant function, we know that a line usually has a domain of real numbers. So now, well, let's look at writing an expression of the form f over g at x and simplifying it. So if we take that, we have 2x squared minus 13x minus 7 all over 2x plus 1. And we're supposed to simplify it, so we're going to write and factor it. You can use decomposition, or you can use guess and check, which I'm going to do. This is over 2x plus 1. So I think this is probably going to be, we need to have minus 13. So that's probably going to be minus 7. That's probably going to be plus 1, which makes sense with the bottom. So that's the factor of 2x squared minus 13x plus 7. We can cancel these, and therefore in our simplified version, we end up with x minus 7. But that doesn't change the fact that we still have a restriction on the domain, and our non-permissible value is x such that x, or our non-permissible value is x cannot be equal to minus 1/2, and therefore our domain is x such that x cannot be equal to minus 1/2, but other than that, it can be an element of reals. And the two methods you could is, again, just like the multiplying, I could use this formula to find out my f over g at 3, or I could find f at 3 and g at 3 and divide those two values. I think I choose this one because it's easier. Okay. All right. And please continue with your assignment, and we'll talk about it in class if you're having any troubles.